Hey guys, this is going to be what you need to know for the midterm. Our first topic that we're going to talk about is scientific method and lab skills. Remember, when you're setting up a scientific experiment, what you want to do first is identify your independent and dependent variables. So the first thing we have is our independent variable. If we think back to the beginning of the year, when we're looking at independent variable, the thing that we want to remember is that this is going to be the if part of our hypothesis. The other idea that we want to remember is that this is going to be the thing that I control or the thing that I'm changing in my two groups. The other thing that we might want to remember is that when we write something out like the title of an experiment, we always have the effect of blank on blank. Now remember that first blank that we're going to fill in, that is always going to be our independent variable. Once again, that means that that's the thing that we are changing in our experiment. The second part of that is going to be our dependent variable. Our dependent variable we're going to talk about in 1 second. Now, our dependent variable is the then part of your hypothesis. Remember, your hypothesis is simply an educated guess. The other thing to note about your dependent variable is that this is the data or the numbers that you collect as you are conducting your experiment. So let's think back to the Making Connections lab that we did most recently. In the Making Connections lab, our independent variable was the thing that was different in the two groups. So for the Making Connection lab, the thing that changed was actually the amount of exercise. Now, that's because one group was resting and the other group was exercising for 1 minute. Next up, we have our dependent variable. The dependent variable is the data that you are collecting. So as we had one group rest and then the other group exercise for 1 minute, we then had an activity that each group had to perform. The activity, the data that we were collecting, was actually the number of clothespin squeezing. Now, speaking about those two groups, we had one that was resting and then one that was exercising. The first group that we have was known as the control group. The control group is the one that receives the normal treatment, normal, everyday, regular. This is going to be the group that we're comparing our experimental group for. In this case, the experiment Making Connections, the control group was actually the group that was resting. Our experimental group is going to be the one that receives the treatment. The treatment in this case was actually the exercising. Another key idea that we want to remember is how can we make our experiment better or increase the validity of our experiment? There are two ways that we can increase our validity. The first way is that we can repeat the experiment, right? Perform the same exact experiment following the same exact steps. And when we do that, we should get the same exact outcome. The other way to do that is to increase the sample size. So instead of maybe working with a class that has 20, 25 students, we would pool the data from all of the classes so that we have more data to look at, to examine, and to compare. The final thing that we need to know about is how to use different types of scientific tools. The first tool is going to be the graduated cylinder. When we're looking at the graduated cylinder, remember, you want to read from the lowest point. Now, the lowest point for the graduated cylinder is going to be called the meniscus. The other thing to note is that we may have to use a ruler to measure. When you're using a ruler to measure, you always want to make sure that you note the starting point for that specific ruler. Sometimes, especially in region style questions, they don't start at the 0. They might start at 1 or 1.5, and you have to take that into account when you are measuring something. Also, another thing important to note is the unit of measurement. Are they measuring something in millimeters or are they measuring something in centimeters? All right, so what I would do is take a couple of seconds, work through those review questions, see what you do and do not know. All right, going over the review questions. The first question is looking at a graduated cylinder, and it wants to know what is the volume for this specific graduated cylinder. What you're going to have to do is actually look at that lowest point. Remember, that lowest point is going to be referred to as the meniscus. From there, you're going to start here at where it says 10, and then you're going to try to figure out what the scale is for that graduated cylinder. As I go and I count up, I have 1, 2, 3. That's going to be 13. That would make the correct answer for this 2. Important to note, they give you 10.3 as the first one. That's just to make sure that you're checking the scale on that graduated cylinder. That scale is going up by ones, not 0.1. They put number 3 there to kind of fool you to make sure that you're actually reading from the lowest point. So you can cross that one off. And then the final one's 15. 15 really has no significance in this because no line for the water goes up to 15. The next one is looking at a worm. And what they've done here is they actually have not started at the 0. Because of that, you want to go and look actually what the measurement is that they're starting at. That's going to be 1.6 centimeters. If I look all the way to the right on the worm, what I'm going to see is that it goes up to 10.6. Now, a lot of people want to go and say, oh, 10.6, I have my answer, and they want to gravitate right towards that number 3. It's not going to be number 3, though, because that doesn't take into account that it didn't actually start at the 0. So we're going to cross that one off. Same thing with number 4, 106 centimeters. No, at maximum, right, this is going to be much less than that. So now we have our two choices, 9 millimeters or 90 millimeters. How are we going to figure this out? Well, I have to take my two values, 10.6 centimeters, and units are very, very important in this, and then minus 1.6 centimeters. That gives me 9.0 centimeters. Look what they've done here, though. If you look at answer 1, it says 9 millimeters. A lot of people immediately want to gravitate towards that, but the units are incorrect. So we're going to cross that one off. Now it says 90 millimeters. You may or may not remember from the beginning of the year, but when we're going from centimeters to millimeters, what we want to do is we want to take that decimal place and we're going to move it over 1 to the right. That gives me 90 millimeters. Remember, moving that decimal place over 1 to the right is the same exact thing as multiplying it by 10. All right, scrolling down, what you're going to see is a series of questions about the scientific method. Number 3 says, in an experiment to determine the effect of exercise on pulse rate, a student checks his pulse rate before and after exercising for several minutes. The purpose of checking his pulse rate before and after exercising is that. So why would he want to check it before he exercises? Well, that's a really good question. He's going to want to check it before he exercises because he needs to have a baseline. Now, why would you want to have a baseline? That's going to be because he needs a comparison. So number 1 says serves as the conclusion. Well, a conclusion is an end product. We're not looking for the end result. We're looking for the very beginning. Okay, so we can cross that one off. 2 is needed to justify his sample size. Sample size means the number of participants. If he's checking his own pulse rate, there's really not too much to do with sample size there, right? We're not talking about the number of students involved. Number 3 says serves as a control. Remember, control group is going to be the whole point of that comparison. And that's why you'd want to go and check your pulse rate before you do an actual scientific experiment. 4 says is needed to formulate a hypothesis, meaning make a hypothesis. You wouldn't need to check your pulse rate before in order to do that. So we're going to go cross that one off. Best answer choice there is going to be 3. Number 4 says in an experiment to test the effect of exercise on the number of times a clothespin can be squeezed in 1 minute, the dependent variable is. Whenever I see a statement like this, what I do is I take what would be the title of, let's say, a graph or a title of a data table. And it says the effect of. blank on blank. Using my strategies, what I would do is I'd say, hey, there's exercise. To the left of the on, that's always my independent variable. And then to the right of the on is my dependent variable. Also remember, dependent variable is going to be the data that you collect. So in this case, the dependent variable is going to be my number of squeezes. Test subject, nope. That doesn't have anything to do with independent, dependent. Amount of exercise is actually my independent variable. And the clothespin, nope, doesn't have anything to do with that. So the dependent is the data I collect. It's also going to be on the right-hand side of that title statement. Scrolling down, we've got number 5. Again, looking at those concepts of independent and dependent variables. Read through the entire statement. It says an investigation is carried out to determine the effect. Second I see effect, what I do is I underline that statement because that's going to be really important. It says the effect of exercise on the rate at which a person can squeeze a clothespin. Again, I divide that kind of into